So number one is sketch the graph of a continuous function for all x within the domain of f of x with the following characteristics. So maybe let's start off by putting down the points that we know. So they gave us some points here. That'll work. So f of negative 2 is 1. F of 0 is negative 2. F of 2, 4. And f of 7 is 0. Okay, so we got points. What next? F prime of 2 does not exist. Okay, so f prime of 2 does not exist, so something's happening there. And f prime of 0 is equal to 0. So what does f prime of 0 equals 0 tell us? Local max or min? Local min. And if it doesn't exist, asymptote or a hole in the graph or a corner. So well, okay, can't no. So f of 2 exists, so it's not an asymptote, and it's not a hole, so it's got to be a corner. F double prime of x is greater than 0 from negative 2 to 2, negative 2 to 2, and from 6 to infinity. What does that tell us? Concave, thank you. The audience is waiting, so it's concave up. The limit as x approaches 6 from the left of f of x is negative infinity. And the limit as x approaches 6, so it's something here. So what's at 6? Asymptote. Okay, so that's going to be going down here and up here. And the limit as x of f of x is equal to 4 as x approaches negative infinity tells us that there will be a horizontal asymptote as we are heading to negative infinity. Okay, can you sketch something? So what do we know? We're concave up here. That's a minimum. So that has to be a minimum because that. So this is probably going to head off like that. This is going to come down here. Have a minimum. Climb up, and we're concave up in this interval. So concave, concave up in this interval. And then we hit a corner. We'll probably do a deep dive. And then likely. How's that seem? So if you do get one of these, just go back over it. When you've done it, make sure, do I have the points? Okay, what I have drawn seem reasonable? Are we concave up from here to here? Are we concave up? here. Our derivative, first derivative not exist at f of 2. Seem good? I'm gonna pause. Okay, so here's our first function, x squared minus x to the fourth. Very nice polynomial, right? So its domain is what? Every polynomial ever. A domain. Do A. What's the domain? You can go with x belongs to the reals if you like. I mean, technically, I suppose the set of all x such that x belongs to the reals. Intercepts. So x x-intercept, how do we get that? Let's do the y-intercept first. Okay, so y-intercept, what do we do? It's f of x, I'm going to call it y for now. So x-intercept, or sorry, y-intercepts at x equals to 0, you get y equals 0. So 0, 0, right? Obviously, the x-intercept is just going to be 0. But x-intercept at y equals to 0 leads to x equals 0. Okay, so intercept, we got 0, 0. Next, symmetries. How do we do symmetry? How do we spell symmetry? Oh, there are 2 N's. Symmetry. So we work out f of negative x, right? And then we see what we get. F of negative x is negative x quantity squared minus negative x to the fourth, which will be x squared minus x to the fourth, which is so if f of negative x is equal to f of x, we have even symmetry. Okay, so it's going to be symmetric about the y-axis. About the y-axis. Okay. D. What's D? Asymptotes. Are there any vertical asymptotes? No, right? I mean, you need a denominator that's 0. Yes?
For the intercepts, like, shouldn't it also be x equals -1, x equals 1?
Which, oh, like x-intercepts?
Yeah.
Right. Right. Go back up. What? Yeah. Is that why? Yeah, you're right. It's not just. Okay, so what do we got? 0 is x squared minus x to the fourth. X squared bracket 1 minus x squared 0. So what do we got? 0, 0. 1, 0. Negative. So if they're easy to find them. If they're not easy to find, don't spend 20 minutes trying to find intercepts of things. But yeah, in this case, you're quite right. That was easy to find. Vertical, none. Horizontal. There we go. Oh, Yeah, I'm on the right page here. Any horizontal asymptote? X goes to infinity, we're just going to get infinity, right? Or negative infinity. Likely. So, none. E. So if there are none, you don't have to find them, obviously. Intervals of increase, decrease. Which is then going to kind of very naturally lead into local max and min, right? But okay, so now what? Now the actual calculus stuff, right? So what do we got to do? Find the first derivative. Okay, and then we need a factored form of that, right? But keep in mind the original because it's going to be very easy. Yes, I know, go look at the old video, I blew it. But it's going to be very easy to find the second derivative of this, maybe even correctly this time around. But you want to find the second derivative from the first derivative, not from its factored form. Yeah, what do we got? 2x, 1 minus 2x squared. So what are our critical numbers? Yeah, so f prime of x. So it's defined everywhere, right? It's defined everywhere. So we would look for where it's not defined, which in this case, but it's defined everywhere. So is defined everywhere. Everywhere. And f prime of x equals 0 means x equals 0, or 1 minus 2x squared is equal to 0. So 2x squared is equal to 1. X squared is 1/2. And x is plus or minus 1 over root 2, which would be root 2 over 2, right? Which also came in as part of our useful information, right? So we will be using that. Root 2 over 2. Okay, so our next step is to do up a table. Yes, we can do over here. Negative root 2 over 2. So keep in mind, so what they've told us is that's about 0.71, negative 0.71. And we got 0. And we got root 2 over 2. And we've got a factor of 2x. You got a factor of 1 minus 2x squared, which will give us the sign of f prime of x, which will give us information about f of x. Okay, fill in the chart. Okay, so we filled in our values here, so that makes f prime of x positive, increasing, negative, decreasing, positive, increasing, negative, decreasing. So we can state, so remember this one is intervals of increase and decrease, so we need to state that. So f of x is increasing from negative infinity to negative root 2 over, rewrite that. F of x is increasing negative infinity to negative root 2 over 2, and from 0 and union to root 2 over 2. And f of x is decreasing negative root 2 over 2, 0, and root 2 over 2 to infinity. Start up. All right, so let's go right underneath here. So F is local max min. Okay, so we know there's a local what? Local max at negative root 2 over 2. So local max at negative root 2 over 2. And where else? Yeah, I mean, it's symmetric about the y-axis, right? So it kind of has to be root 2 over 2. So we only need to work out one of those. Let's do the positive one. So f of root 2 over 2 will be root 2 over 2 squared minus root 2 over 2 to the fourth. So what's that going to be? 2 over 4. So 1/2. And what's that going to be? 4 over 16. 1/4. So that will be half minus quarter is 1/4. Okay, so let's say local max negative root 2 over 2 1/4 and root 2 over 2 1/4. Local min, where's the min? X equals 0. Okay, so we already know that point, right? 0, 0. Let's slide this up a smidge. Yeah. So let's go here. We'll go over here for G, which is concavity. And point of inflection. F double prime of x. So I positioned this under here. I mean, you may be flipping a page or whatever. I mean, it doesn't really matter. See if I can do it right this time. It's 2 minus 12x squared. 2 minus 12x squared. And what's that going to be then? 2 bracket 1 minus 6x squared. So if double prime of x will be 0 when 1 minus 6x squared is equal to 0. 6x squared is 1, x squared is plus or minus 1 over root 6. Or plus or minus root 6 over 6. And we'll just leave it. Yeah, because our number came in as 1 over root 6 on the thing there. So. Okay, so we need a new chart. If I can squeeze everything in on one page. Negative 1 over root 6. 1 over root 6. We got a 2. 1 minus 6x squared. Which is going to be what? Negative, negative, positive. So f
double prime of x is negative, positive, negative, CD, CU, CD, POI, POI.
Okay, so from the chart, we've got the concavity. I guess we should list that. And we also have the points of inflection. So let's list our concavities. F of x is concave up, where from negative 1 over root 6 to 1 over root 6. F of x is concave down, negative infinity to negative 1 over root 6, and 1 over root 6 to infinity. Okay. And again, that's because of symmetry. Right. So I mean, this shouldn't be surprising because it has to be symmetrical about the y-axis. And our point POI, f of 1 over root 6. So we just need the 1. I mean, they're both going to have the same value, right? Because symmetry and squared and fourth. So 1 over root 6 squared minus 1 over root 6 fourth. So 1/6 minus 1/36. 5/36. Can't do it. Okay, so our POI, negative 1 over root 6, 5/36, and 1 over root 6, 5/36. We got it all. We got root. Oh, look, that space up top there. Just going to squeeze this onto one thing. Okay, so what have we done? So going back to our intercepts, we have the y-intercept at 0, the x-intercept at plus or minus 1, negative 1, 1. We've got no asymptotes. It's symmetrical, intervals of increase and decrease. Negative into negative root 2 over 2. So they gave us that, right? 0.71. Let's put that there. Negative root 2 over 2. 2 over 2. Keep that in mind. It's increasing to that. Where's our max and min? We got local min at 0, 0. Local max at 1. Root 2 over 2 and 1/4. Let's make that 1/4. Okay, so we got the local maxes and mins. Okay, what else? Okay, so points of inflection, negative 1 over root 6. So what was that? 0.41 and 5/36. So 1/4 is 9/36, right? So at 0.41, 1 over root 6, negative 1 over root 6, 1 over root 6. And somewhere about here, 5/36, so there's points of inflection there. All right, we're ready. So what did we have? It's increasing, so it's increasing and it comes up to a maximum. And then it's concave, so it's going to be concave down in this interval, right? Up to here, where here. It's going to change to concave up, that's our minimum. Change back to concave down, and head down. And there it is. X squared minus x to the fourth. So we should have these max. Right? So 707 and 1/4. So what do we say? Negative root 2 over 2 and root 2 over 2 and 1/4. We've got our intercepts there, and then our various points of inflection, which won't be labeled on there. Okay, go away. Domain. What's the domain? So it's polynomial. Negative infinity to infinity. Intercepts. Y-intercept is what? Negative 3. X-intercept x to the fourth minus 2x cubed minus 2x squared plus 6x minus 3 equals 0. Ruh-roh. We can do this. You have the skills. 3-1. The remainder theorem. Okay. So it says if there's a factor, it's going to be, if there's an integral factor, it's going to be a factor of negative 3, right? So plus or minus 1 or plus or minus 3. So, I don't know, let's try 1. What happens? We get 1 minus 2 minus 2. So that's 1, say, plus 6. I think that might actually work. Right? Let's give it a try. Try x equals 1. This really is a try. I kind of think it's going to work. We'll find out. What do we got? 1, negative 2, negative 2, 6, negative 3. All right, so what do we do? Bring that. We get negative 1, negative 2 minus is negative 1, which is 1, which is negative 3, which is 3, which is 3, which is negative 3, which is, well, it worked. All right, so what have we got? We have p of x minus 1, x cubed minus x squared minus 3x plus 3. And you get to do it all over again. No, it's x to the fourth, not 4x. It's the coefficients. Well, we could try 1 again. What do we got? 1 minus 3 plus. It's actually going to work. Okay. Let's try x equals 1. So 1x cubed minus 1x squared minus 3x plus 3. I don't need to write plus. 1, negative 1, 0. Negative 1, yeah. 0. Negative 3, 3, 0. It's like, here we are deep into a math 30-1 problem that we thought was like, oh, this is really complicated. Having to do it. And then it's just like, what? We're just finding the intercept. Okay, so the x-intercept. What do we got? 1 and plus or minus root 3. So it's going to give us 1, 0, root 3, 0. All right. Okay, we've done B. C. Symmetries. What do you think? Is there going to be any symmetry? X to the 4 plus 2x cubed minus 2x squared minus 12x minus 12x minus 3, and that's like totally different, right? From our original. Oops, come on. Ooh. Right, we got a 12x now, and so. Wait, where did I do that? Sorry. That's minus 6. Hold on, plus 6 times negative x minus 3. Okay, so minus 6x minus 3. All right, so it's not the negative of something, right? So no symmetry. No symmetry. Asymptotes? No, I mean, it's a 4th degree function. It's just, we know it opens up. Right? It goes up forever. So no asymptotes. There's no denominators. There's no radicals. Right. Intervals of increase and decrease. So now it's on the first derivative, which is P. 4x cubed minus 6x squared minus 4x plus 6. So they're all even. 3. And then it should be what? Like again? What? Did I mess it up? Yeah. Okay, good. That could have been disastrous. Well, we need a factor. What's it going to be? Well, 1's been working so far for us. Let's just keep trying 1. What do we get? 2 minus 3 minus 2 plus 3? That should work, right? 2 and then minus 3 and then minus 2. Try. So don't forget the 2. The 2 is still part of the factorization. Now, it's not really going to do anything here, but if that was a negative 2, then that would definitely do something, right? When we go to look at the intervals of increase and decrease, we need the sign of that factor. So normally we would just kind of ignore that, okay? But we can't ignore this. But for now, we're just not going to bother. We're going to try it. So we've got x minus 1. I'm interested in this. So the 2, negative 3, negative 2, 3. 2, negative 2, negative 1, 1, negative 3, 3, 0. Okay, so for 2, it's an x minus 1. And can we factor the quadratic? Two x, 3, 1, minus plus 2 minus 3, yeah, minus 3, yeah. Okay, so the critical numbers. One, 3 halves, negative 1. Okay, let's go over here, make a chart. Negative 1, 1, 3 halves. So I'm putting the 2 in as a factor because I don't want to forget, right? If that was a negative 2, that would definitely make a difference. Right? Because then this thing would be opening down. If there had been negative x to the fourth, whatever, that would be a negative, it would open down. So don't ignore that constant factor. X minus 1, x plus 1, 2x minus 3. Will give us p prime of x, which will tell us about p of x. So, fill in the table. Three minus 6. Increasing negative 1 to 1, and 3 halves. Okay. Decreasing. Okay. That should fit with the narrative, right? Because we know it's a fourth degree, it's opening up, so it's got to be decreasing as it comes from negative infinity in. It's got to be decreasing, and as it heads out to infinity, it's got to be increasing. So, matches with what we know. What's next? Local max and min. Right? So we squeeze this in. F, is that F? Yeah, local max min. Get this down. So we've got a minimum, a local minimum at x equals negative 1. So local min f of negative 1. We got 1 plus 2 minus 2. minus 6. Minus 3. We got 3 minus 3, that's going to be negative 8. Local max at 1. So that's local max. Minus 2 plus 6 minus 3. We got 7, that's 0. So local max at 1 is 0. And a local min at 3 halves. Why 3 halves? Halves to the 4th minus 2 times 3 halves cubed minus 2. 3 halves squared, that's 6. All right. So our first denominator is going to be 16. So it's probably best if we keep all the denominators as 16 as we work these out, right? Because we're going to need 16. So like we'll need a common denominator. So this is going to be 81 over 16. That's going to be, see the 2, like you might want to cancel the 2 in that, but let's not do that. So this will be 27 over 8, 54 over 8. We're going to double 54. So 108 over 16. That'll be 9 quarters, call it 18 over 4. Call it 72 over 16. That'll be 18 over 2. So call that 18 times 8, 80 and 64, 144. And 24 over 16. Okay, and so which one? Oh, right. 48. Okay, what do we got? On the plus side, we'll have 14225. On the minus side, we got 180 minus 228. So negative 360. Yeah, that's right. Thanks for the save on the 360. Slide this out. So G, concavity. And PO. It's P. Okay, so P double prime of X. So go to the original P prime of X. there. 4x cubed minus 6x. Don't use the factored form. Right? Just go to the original. You can probably see what I have written down. Okay, what do we got? 12x squared minus 12x minus 4. Okay, so check that over. Make sure that that's right. That is not going to factor, right? 3x squared minus 3x minus 1. Out comes the quadratic formula. Right. Not on your formula. It should be on your formula. It's like on every formula sheet. Yeah, there it is, right at the top, right? In the big square. Not the right thing, not square. But I know the difference. There it is, right? In grade 10, no, you don't do quadratic formula in grade 10, do you? Can't remember. All right. What do we got? 3 plus or minus the root of negative 3 quantity squared minus 4 times 3 times negative 1 all over 2 times 3. So we got 9 plus 12, 21. Over 6. Is that one of our nice numbers? Oh yeah, there they are. 3. Oh, and they gave us F of, so that's nice. They saved us. So next step is the chart. 3 minus root 21 over 6. 3 plus root 21 over 6. We got 4, is always positive. And we've got the 3x squared minus 3x minus 1. This is actually easy, right? This is a quadratic that opens up. So it's doing this. Okay? So it's just plus minus plus. P of x, CU, CD, CU. So P of x is concave up, negative infinity, 3 minus root 21 over 6, and 3 plus root 21 over 6, infinity. And it's concave down. Plus. And we got a TOI here and here. But those are pre-calculated for us, right? So they are at what? Negative 0.26, negative 4.7, and 1.26, negative 0.
So on a test, for like this portion of it, will we be given like the information of like the pre-calculated score?
If you needed that, yeah. More likely we're just going to give you easier numbers. Yeah, we're not going to have you. Yeah, you know, can you throw will you perhaps have to throw 3 halves into an x? Maybe, I don't know. But I mean, that's not testing much calculus, right? It's just, can you calculate this part? No. Oh, no. Well, that's it. 8 marks. Done. So no, we tend to break it up. Sketch time. So where do we start? Intercepts, right? Intercepts. Where is that? It's like 4 pages back. What do we have? A y-intercept at -3. X-intercepts at -√3, 1, and √3. Okay, what else? It's a fourth. We already know its shape. Like it's coming down and then doing stuff and then going up. So where were the min? Local min at -1, -8. Gonna move this way. So there's our local min. Local max at 1, 0. That's a local max. Oh, another local min at 3 halves and -3/16. All right. So it's going to come down, that, and then go. So do this and that, and we just want to put that together with our concavity. So we had a point of inflection at -0.26 and -4.7. I'll do the POI in red. Point of inflection there, and 1.26, and a point of inflection about there. Okay, so we're going to come down. We'll be concave up, switching to concave down, switching to concave up. Up and away. There it is. There's your min. That. That. Okay. Oh, that's hard. Any way to get a 0 down here? Nope, that's where it's +1. Right? Okay, so all real numbers. And let's be intercepts. Sorry, what was this? Q of x. Set x equal to 0. What do we get? 0. X-intercept? No. Yeah, x-intercept. No, wait. Y-intercept? Yeah, x-intercept. So that's just going to be 0, 0, right? Because we're going to multiply. 0 is 4x squared over x squared plus 1. Okay. Symmetry. Q of negative s. What kind of symmetry? Even? So it's a reflection about the y-axis. What's D? Asymptotes. Any vertical? No, the domain's all real numbers. You can't have a vertical asymptote. Horizontal. Oh, we got to do work. So how do we do these horizontal asymptotes? So how do we do? What's that? Divide everything by the highest power of x? That should work. So you have to, I mean, we know it, right? It's just 4, right? We can look at it, but we got to show it. So it's going to be 4. Intervals of increase, decrease. Ooh, practice time. We're good. I see one head nod. So critical numbers just going to be 0. Right? That's always positive and defined. So critical. Go to Q. Q prime of x equals 0 means x is 0. So what do we got? X. Negative, positive, 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 negative, positive. That's Q prime of x. So Q of x. Increasing, decreasing, 0, but we already know it's 0, 0.
Con.
Uh, 8x. No, but that's low D high. We're doing the second derivative. Just so, I mean, this is the easy. Just, I mean, there is no nicer, different form of this. It just is what it is. Okay. God. All right. So we're gonna have what? Well, at least an 8 and an x squared plus 1. So, x squared plus 1 minus. Okay. What do we got? We got the 8's taken care of. We're gonna have a 2 4x squared. Negative 3x squared. So 8, 1 minus 3x squared, and x squared plus 1 quantity cubed. Is that one of the nice? They didn't give us any nice numbers. You can leave it as 1 over root 3. You can write it as root 3 over 3. I don't know. 6 1, half dozen the other. We know it's even symmetry. Plus every x is squared, right? It's like x squared over 4x squared over x squared plus 1. So whether we do plus 1 over root 3 or minus 1 over root 3, we'll get the same value. Four thirds over 4/3. Timing is really magnificent. So what do we got? Well, the domain is all real. We have point at 0, 0. We have that's our local max or min. Oh, we got a horizontal asymptote at 4. So we're going to be coming from below on that. We've got concave down, concave up. We have points of inflection at 1 over root 3, negative 1 over root 3, 1 over root 3, 1. So we got point of inflection here and here. We're concave down, so we're going to come from here, change, go up there. There we are. And wait for it. And there we are.